Hello. This is a way to show you how to perform the experiment number 2 in FED. And the reason I made this video is to make sure you remember how to use the ammeter properly, because if it is not inserted in series with a component, that's going to lead to a blown fuse, which will delay your ability to perform the experiment. So the first experiment, the first part of that experiment, is about a series connection of resistors. There's a 1K and 220 ohms. And in that case, I'm showing how to use the voltmeters across the battery, across the 1K, across the 220. In this case, obviously, it's a combination of both. The voltmeter, the ammeter, and the resistor, only because the ammeter has ideally 0 ohm, so it doesn't matter if you put it straight across the 220 or the combination. So we needed the voltages to verify Kirchhoff's voltage law, but I also needed the current in the circuit. Obviously, it's a matter of breaking the circuit connection, and in this case, I broke the connection between R1 and R2 at this point, and I inserted the ammeter in series with them. And obviously, I'm measuring the current flowing clockwise, and so the current enters the positive terminal. That means this is your red connector, your red part of the cable, and this is the black part of the cable that is connected to the resistor. And now I'm going to show you how that circuit is put together on a breadboard and how the measurements are made, mostly from the current point of view. So obviously, as far as the circuit on a breadboard, I could have done it in ways that I could minimize the number of wires, but in this case, that is the point, by connecting the power supply directly to the circuit. But in the future, when your circuit becomes more complex, you have to learn to use these strips with the red line, the red rows, where all the connectors are connected together. The blue ones, the same story. So in this case, for example, I'm using this blue line of connectors as the ground, right? And so whenever I connect anything to the blue line, that means they're connected to ground. And then I'm powering the circuit directly. So if you remember the circuit, it goes from power to the resistor, to the other resistor, hopefully in series, but in this case, I broke the connection between the two resistors because I want to insert the ammeter. And if you remember, the current flows this way, goes into the red connector of the ammeter, and the black connector goes back to the resistor, and now the ammeter is in series, as you see. And if you remember, for the measurement of the current, the cable, in this case, for this particular multimeter, it goes, the measurement of the current has its own connector here, where the plus of the cable is connected. That means it's equivalent to the red. And so when we set the meter to DC current measurements, right? So I measure about 4.14 milliamps, and that's about the current that you expect from that circuit if you work out the expressions for KVL or Ohm's law also, right? And you will see, you can verify that that's the value. Now for the parallel connection of resistors, as you see here, I need to measure the current through the two resistors, right? In fact, through the total current, which is measured here, coming from the battery, and then measured through each resistor. And this is the circuit that allows us to verify Kirchhoff's current law, which says that the total current should be the sum of these two currents. And as you see here, the ammeters again are inserted in series, right, within the circuit, in the path of the current, in the path of the current, and in the path of the current. And so the currents are in this direction and down. And in this case, that means the red connector is here. This is the black connector, red connector, black, red, black. And then in this case, we are going to obtain positive values. As far as the circuit is concerned, it may not be ideal in terms of number of wires that I would use, but I just wanted to make sure that the measurements are clearer. And so, like in this case, for example, if I send the power to that circuit where the plus is connected to this connection of the two resistors. See here, they're connected together through this wire. Here they're connected together because it's the blue line, and so they are in parallel. And so in this case, now I'm powering up the circuit. Now I have to figure out how to measure the currents. For the total current, as if you remember from the circuit, I had to insert the ammeter between the power and the circuit. And so in this case, since the current is flowing in this direction, that means the red connector goes to the positive of the power supply, and the black connector goes back to the circuit, and that allows me to measure the total current, which in this case happens to be about 27.5 milliamps. Obviously, again, if you work out Ohm's law and KVL, KCL, we'll find out later on that those numbers make sense. However, for the currents, for the measurement of the current through the two resistors, it becomes a little bit more complex in a sense that I will have to break the connection between this resistor and this point so that I can insert my ammeter in there. And so the way to do it is I remove one terminal, I put my red connector into this point here, right? This is the current going into the ammeter and back into this specific resistor. And so that would happen when I connect the black connector. And now I am measuring the current through this resistor here, which you can see to be about 5 milliamps. Again, later on, if you divide V by R, you will find out that that current makes sense, has a valid value. And of course, I do the same thing in this case with the other resistor. So I remove the connectors, I put back the resistor where it was, and I just repeat it by removing this terminal for this resistor. The ground is still in the same place, but now again the positive or the red terminal goes into the common point, and the black connector goes into the resistor. And in this case, I'm measuring the current through this specific resistor. And if you look at the value, it's about 23 milliamps. And if you verify KCL, the sum of the two was equal to the total current. So my final advice is that you prepare these two circuits together on the breadboard at home before you come to class, so that you can spend your time verifying other situations or verifying other conditions, or most likely ask more questions to learn more from.